All right, so today we're going to look at, these would be, this would be the second type of problems. And we're going to resolve vectors into components. So it's more using sine, cosine, and a single angle to figure out the legs of the triangle. So when I say this term vector component, we should probably talk about what that is. Paige, can you see okay? Yeah. Okay, because if it would help you to like sit in that second desk and move it over a little bit, you can do that like you used to sit. All right, so vector component, when I say that, I'm talking about the horizontal and the vertical. It could be displacements. It might be velocities, whatever it is that you're given. Pieces that add to give you the resultant. So when you hear that vector component, you're either talking about the horizontal or the vertical portion of the triangle. When we think about this, we're going to have an x component, and that one will be parallel to the x-axis. And you're going to have a y component. Which obviously is going to be parallel to the y-axis. So notice this says resolve into components. So these are the things in these problems that you're going to be solving for. Okay, so when I work with these, it's going to look one of two ways if you think about thinking about it in terms of a triangle. You could be given your R, will be given, and whatever this angle right here is, it'll be given to you in the problem. So you've got that. The pieces that you have to find in this case, I don't know how well that's showing up, will be your x and your y components. So you've got two givens and you have to find two things. Does that make sense? Questions? All right, so before we start solving these, there are some things that you need to remember. Oops. So some things that you need to remember. Your component vectors, your x and y, in the end, can be positive or negative. going to end up depend on what quadrant you're in. Just like it did in math. Remember the 4 quadrants? Some are positive, some are negative. X and negative Y. Positive X, positive Y. Do you know what I'm talking about? Okay, Braven's saying yeah. All right. Second thing you need to remember, that you should remember from math. Any vector, doesn't matter the magnitude, it doesn't matter the angle, can be described using a set of perpendicular components. We've already done that. Now we're going to do the reverse of that. And the last really important thing when we talk about this is that we can, let's say by breaking a single vector which would, in this case, when we're working these, which would be your resultant. What leg of the triangle is the resultant always in these particular questions? Yeah, your resultant or your hypotenuse into its 2 components. And that's called resolving a vector. So it's really important that we key into these words, because the different problems will be worded differently, but really pay attention in your problem to whether you're given 1 vector quantity with an angle or whether you're given 2 vector quantities. If you're given 2 at this point, you know, oh, I'm solving for c squared, I go to my Pythagorean theorem, the resultant is my hypotenuse. If I have a problem where I'm only given 1 vector and an angle, then in your brain you should go, okay, this is the resultant. I know I have to find my other 2 legs of the triangle. Does that make sense? Okay. So let's see a little bit more we should probably go over. Let's say using resultant to find components. So we're going to use the direction and magnitude of vector given, which is your resultant, to solve for x and y. And actually, I think these are really pretty easy problems. To do that, we're going to use the function of sine and cosine of the angle. So we probably should review what those are, just in case you don't remember. Sine theta, or sine of the angle, is equal to opposite over adjacent cosine theta is equal to what? Adjacent over hypotenuse. Find my mistake. Do I have one?
Yeah.
Yeah, what is it?
Opposite hypotenuse.
Yeah. Thinking ahead of myself. If you want to, at this point, I'm okay with you putting these two things on your card if you're a person that uses your card. If not, you've got them in your notes. But if you want to take a second and put them on that card, you can. If you can still find your card. The third thing I want you to think about when you do these is that you should think of these as triangles. So really we end up with a case where we've got our r, we've got our x, and we've got our y, which represent in the Pythagorean theorem a, b, and c. It works out the same kind of way. So let's think about a problem here. Let's say we have a plane traveling 95 kilometers per hour at an angle of 35 degrees. And then it might say something like this: find the vertical and horizontal components of this vector. Now, before you do anything else, well, write that down and then I'll tell you what I want you to do. When you do these things, the first thing I want you to do is to write down what you're given. So this 95 kilometers per hour represents what? Good, the hypotenuse. Or what is the hypotenuse? The resultant. So my r equals 95 kilometers per hour. What else do I know in this problem? Yeah, I know my angle. It's 35 degrees. Then what I want you to do, and I'm not really concerned with using a protractor and finding the actual degree of the angle, but in your head or on your paper, I want you to think about that. 95 kilometers per hour and 35 degrees. I would actually like to see something like that. And then I want you to draw in your y and your x that you're solving for. And normally, you got to read these problems and see what they're asking you for, vertical or horizontal. In this case, you are asked for both of them. So we're going to start with, because normally you do, we want to find the magnitude of x. Which side of the triangle is x? Adjacent or opposite? Okay, so I know I have to use cosine when I have x. So I have cosine of the angle equals adjacent over hypotenuse, or x over 95 kilometers per hour. So let me rewrite that. Cosine of 35 equals x over 95 kilometers per hour. Now, before you calculate, make sure you're in degrees. So when I show my math, I have cosine 35 degrees times, what was it, 95 kilometers per hour equals my x, or my horizontal component. I'll let y'all punch that in. You got an answer already, Kylie? What is it? 78 kilometers per hour. And look, she even gave me the answer and the correct number of sig figs. Punch it in your calculator, though, and be sure that's what you get. Because if not, we've got some problem going on with your calculator. Or the way you entered it into your calculator. If you get some really weird number, immediately check your mode and make sure you're in degrees, not radians. Ooh. Oh. Hold on.
Yeah, 'cause I did not.
Do cosine 35 and hit enter. Do this, Jaden, if you didn't get it. Cosine 35, hit enter, and then times 95. I did something wrong. I hit my sign. Cosine 35 times, what is it, 95? I got 77.8. Did you get it when you put it in that way,
Yeah.
Jaden? Okay, all right. Are we good? Okay, so then let's look for, ugh, rid of all these papers. Let's look for my y component. When I'm dealing with my y component, it's a little different than dealing with my x component. I have to use sine. Sine of the angle equals my opposite, or my y, over my hypotenuse. And y is opposite. So I have sine 35 degrees equals y over my 95. That stays the same, kilometers per hour. Working through, getting that 95 off of both sides. It looks like this. Sine 35 degrees times 95 kilometers per hour equals y. Put it in the same way. Sine 35 times 95. See what you get. What'd you get, Paige? 54. Is it 54 or 55? How does it round? 54, okay. And that would be kilometers per hour. Now, here's what I want you to try to figure out. And it shouldn't be too hard to figure out. How can I check and see if this is correct?
You can just enter equal 180.
Yes. It's okay. So I can do c squared equals a squared plus b squared, or r squared equals x squared plus y squared. I want you to actually plug those in, and I want you to check it. And the reason, honestly, especially when we quiz on this next week, check it, because sometimes you hit the wrong button and you get the wrong answer, and when you check it with Pythagorean theorem, it won't add up, and you'll go, oh, I've done something wrong, and it'll save you 5 points. once you've got it checked, stand up. You guys standing up, did it check? Okay, so anybody not? Oh, everybody's standing. Everybody's standing. Did yours check?
Yeah.
Any questions? All right. That's where I'm going to stop.